5.1 is a new section on polynomials, and it's a ton of vocabulary. So we're going to start off today with really most of the problems in Delta Math take you just a couple of minutes once you understand what's being asked of you. It's just looking at a problem and then answering the question based on it. You're not really doing a ton of math. So a polynomial function is in the form, and it gives you this ugly mathematical terminology for a polynomial, where you have a sub n x to the n power plus a sub n minus 1. All that's showing is that this is the highest degree. So with last chapter, we did all quadratics. Everything was raised to the second power. Well, a polynomial, which means poly means many, could be raised to the fifth power, the sixth power, the third power. We mostly deal with fourth, third, and second degree polynomials. Occasionally, you'll see a fifth degree, sixth degree, but this is all vocabulary. So this is the mathematical way to show it, where a sub 0 is just a number, it's a constant. This is how I normally show it to students because it allows us to look at this, where this would be a cubic polynomial because it's raised to the third power. We always call the polynomial based on what the highest exponent is. Okay, so this would have 4 terms. So terms are separated by plus or minus signs, and it would be a third degree polynomial. Okay, so we're going to look at some vocabulary here. And again, this is really like the bulk of the lesson is looking at this vocabulary. So the degree of a polynomial is the highest exponent. Leading coefficient, it's when you have it written in standard form, and standard form has the highest degree first. It's the number that's in front of that first term. Okay, we always put a polynomial in decreasing order from exponents, so it goes largest to smallest. So we call them special things based on the degree. So if there's degree 0, it's just called a constant. Like if I had a number that was 6, okay, or 8, those are constants. A linear would be like 3x or 5x plus 2 raised to the first power, okay? Quadratics would be raised to the second power, so like 8x squared plus 4x minus 3. That's what we dealt with all last chapter. A cubic would look like 3x cubed, and again, that could be a cubic polynomial, it just has one term. And a quartic is raised to the fourth power, so 5x to the fourth minus 3x squared plus 2. That would be a 3-term quartic. There's also a degree 5, which is quintic. We're not going to worry about that too much, but it is quintic for a 5th degree. Okay, so I'm going to give you a couple problems here, and this is kind of just what I'm talking about with vocabulary. First of all, I want you to put it in standard form. I'm asking you, is it a polynomial? It's a polynomial if it has positive whole exponents. It cannot have an exponent as a fraction. It cannot have a negative exponent. They have to be whole numbers. Okay, so for this example, is this a polynomial? Yes, because this is a degree 2, this is degree 1, this is degree 0, so yes. Putting it in standard form, I put the highest exponent first and then go in decreasing order. So again, look, I move all of these around. I'm not doing any math. I'm just changing the location of where each term is. The degree is the highest exponent, which would be 2. The leading coefficient would be negative 2, and this is a quadratic because it's raised to the second power. So I want to look at a couple of these. And again, looking at these, is this a polynomial? Do not look at the numbers that are in front. Just look at the degrees. The degree is 1, 3, 4, 2. So is this a polynomial? Yes. They're all positive whole integers. Now put this in standard form. So we're going to move these terms around. It would be pi x to the 4th minus 14 x to the 3rd. Notice how I take the sign with it. The plus means it's positive. I don't put a plus in front of the first term. Minus square root of 2x squared plus 7.4x. So that would be standard form. The degree would be 4. The leading coefficient would be pi. Pi is a number. And the type would be a quartic. Okay. This one right here, is this a polynomial? And the answer to that is no. This is not if it's not a polynomial, I can't put it in standard form. I can't tell you the degree. And it's not a polynomial because it's raised to the x power here. Okay, this one. Is it a polynomial? No. Why no? Because it's raised to the negative first power. This means it's not a polynomial. Okay, so turning points of a graph. So then we're going to look at graphs and we're going to be asked where are the turning points and behavior and then functions increasing and decreasing. This is really kind of where it can get a little confusing, but make sure you stay with me on this. So turning points are where the graph changes direction from left to right. So if you look at a graph, and these graphs are all going to look different, and we're going to be using Desmos and our graphing calculator to graph these. This graph right here would have 3 turning points, okay? This parabola only has 1 turning point, which we know is the vertex from chapter 4, okay? So when we talk about end behavior, I'm asking you, what does the graph do as it goes all the way to the left? Okay, it's either going up or it's going down. And then what does the graph do as it's going to the right? It's either going to go up or it's going to go down. Now, I will say that end behavior will look like this, and it looks a little bit goofy. As x goes to positive or to negative infinity, okay, it'll say f of x goes to, all this is saying is left, and what is y doing? So y either goes up or down, right? So this would be going up, so we would put positive infinity. And then you'll see as x goes to positive infinity, f of x goes to, which again, this says what? As it's going to the right, that's what, as x goes to positive infinity, f of x, y is going to what? What is y doing? So this would be positive infinity. Okay, so looking at this graph, the end behavior would look like this. Okay, and you'll see this in delta math. And then we talk about increasing and decreasing. Increasing and decreasing is always left to right. So increasing and decreasing. Always left to right, which means, spell that right. Come on now. There we go. Okay, which means we're what? We're dealing with x values. Okay, so you're only going to write down x values, and we're going to use inequality notation for this. Okay, so if you look at this graph and I were able to graph this, we would find these turning points, which on Desmos, it's really simple to find. Okay, and that's what we would put down for the x values. But here they give us the turning points. So this is negative 1.07, negative 1.04. This point would be negative 0.27, 0.17, and this would be 0.22. Okay, negative 0.15. So now it says the increasing is the function is decreasing, meaning from left to right, it's going down. I know this arrow is pointing up, okay, but from left to right, it's going down, 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 down from here to here, which means x would be less than or equal to, I guess you could also put x is less than, the x value of this point, which is negative 1.07. Then at negative 1.07, it starts increasing, going up right here to this x value, which is negative 0.27, okay? And then it decreases from here to here and then increases. So you're kind of following from left to right, and all you're writing down is the x values. I cannot stress that enough. Cannot stress that enough. Only writing down the x values, okay? So I want to take a look at a couple of those problems on Delta Math and what they look like. So right here, increasing versus decreasing, okay? So when we look at these problems, it's telling determine all the intervals in which the graph is decreasing. That means from left to right, it's going down. So if we look at this, okay, this is going up, 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 and then at negative 5, it starts decreasing. So it's decreasing from negative 5 So we would say from -5 to, and this is still decreasing all the way down here to -1. Notice how I don't write -7. I'm only writing the x values. So we say -5 less than x is less than -1. That's where it stops decreasing. And then it increases. It increases up to 1. Okay. So then the next interval that it's decreasing would be from 1 to 4. And I haven't put this in here yet. I'm not exactly sure how this is going to mark this right or wrong. Then it starts increasing up to 6, and then 6 to infinity, it goes down. So, no, why did you do that? Okay, so it's decreasing again. Let me put that from 1 to 4. So from 1. Notice I'm only putting the x values, and then it's decreasing from 6 to infinity. So that would be x is greater than 6. Okay. Now they might want you to put greater than or equal to. We'll put the answer here and see what it looks like. Okay, but again, we always put less than symbols because it's everything in between those two values, and I'm only putting the x values, right? It's decreasing from -5 to -7. I know there's a little hump here, but I think it's still decreasing throughout the whole thing. It never really has a turning point up, okay? And there's the correct answer. So again, kind of follow that. If it asks for increasing, it would be what? It's increasing, x is less than -5. It'd be increasing from -1 to 1 and increasing from 4 to 6. So you want to try to give those problems a shot and just follow that along from left to right.